Hello. In this lecture, we're going to learn about factoring a difference of squares. Since the only way we can factor a binomial at this point in time is if it's a difference of squares. If it's not a difference of squares and the GCF between all the terms is 1, then we'll just say it's prime. So it either looks exactly like the formula, a squared minus b squared. In that case, it will factor to a plus b times the quantity a minus b, or else we won't be able to factor it. So our first one that we're going to have is x squared minus 4. Now, we're starting off nice. If we can view this as something squared minus something squared, then it'll fit our formula. The first something we have is x. X squared is x squared. And 2 squared is 4. So now we can factor this using our formula above, in which we'll have the product of a sum and a difference. That's what the formula gives us. And in this case, a is x and b is 2. And we're done. So factoring a difference of squares is very nice as long as you can identify your perfect squares. Let's go ahead and see another one. Let's say, for instance, we're still asked to factor, and we have x squared minus 19. So this is in descending order. There's no GCF other than 1. And we have to figure out if we can write these guys as a difference of 2 squares. Now the first guy we can write, x squared is x squared. But now can we take the square root of 19 and get like a perfect square? And since 19 is prime, we don't actually have anything that can multiply together where we have something squared to get us 19. So since this fails here, and the GCF between the two terms was 1, we will say this is prime. So it's either a perfect square or we can't factor it. Let's see another one. That was a little boring. Let's say we have 121 x squared minus 9y squared. So we're asked to factor this. If we can write these two things as a difference of 2 squares, then we can factor it. Also, I should have checked if there's a GCF. I already assumed that you guys could do it. The GCF here between the two is 1, so there's no greatest common factor. Now, what we're doing is we're looking at 121x squared, and 11 times 11 is 121. X times x is x squared, so 11x, that quantity squared, is the same thing. And 9y squared, we could write 3y. 3 times 3 gets us 9. Y times y is y squared. So it is a difference of squares. So it'll factor perfectly to the product of a sum and a difference, in which our a is 11x and our b is 3y. And we're done. Another very nice one. Let's go ahead and see a little bit different. Let's say we're still asked to factor. And this time we have 49 x squared minus 28 y squared. So the first guy, we can write it as, let's see, something squared minus something squared. That's what our goal is. If it doesn't fit this mold, then we can't factor it. And the GCF between the two is looking actually, I'm actually a bad student. Let me look. Between 49 and 28, is there a GCF? If there is a GCF, then we have to factor that out first before we even tackle this problem. So I jumped the gun. I'm not allowed to start to see if it's a difference of squares until after I've determined that there is a GCF. Between 49, we could break it down. We got 7 and 7. 7's prime, can't go any further. 28, you can do 4 times 7. 7's prime, 4 breaks down to 2 and 2. So between those two, they share a 7. Just one 7 though, we can't double dip. So we so far for the GCF have a 7. X squared, y squared, okay, no variables are the same, so we can factor out a 7. We must do this first. And now we have 7x squared minus 4y squared. What we'll now determine is if we can factor this further. And 7 is not a perfect square. Once again, he's a prime. So since we can't factor any further, the answer is not prime. We did write this as a product. We have the GCF times this polynomial left behind. So this is our final answer. You don't have to write the multiplication. Alright, so it either fits exactly our formula, maybe there's a GCF, make sure you factor it out first, or it doesn't and it will be prime for us. That's all, until next time.